Hey everyone, welcome back. In this video, we are diving into how to create a Google Calendar AI agent to help us to manage our Google Calendar using Python. This is a beginner-friendly tutorial in which I will walk you through every single process step by step. We'll be using Google Calendar API to automate Google Calendar-related tasks and utilizing OpenAI API to create the AI agent. For the UI interface, we will be using Streamlit, a very popular open source framework to build web apps. By the end of this tutorial, you'll have a functional AI agent that can interact with your Google Calendar, performing tasks such as scheduling events, checking availability, and providing summaries of your upcoming appointments. This project combines several powerful tools to create a practical, real-world application of AI in everyday life. Before we dive into the tutorial, let me give you a demo first so you know what to expect. In the web app, I can ask the agent to show my calendars in my Google account. I can also ask the agent to simultaneously create a calendar and add events to it. Some of other functionalities, such as create a calendar, and show specific calendar events. And looks like my prompt in the main agent is flawed. I will fix it once we get into the script development. Now that you have an idea of the AI agent we are going to build, let's get started with the tutorial. The first step is to create a Python virtual environment. Virtual environments are great for keeping dependencies organized, especially when working on projects with different requirements. To create a virtual environment, launch a terminal and run the command python-mvenv, followed by the Python virtual environment name. cd into the Python virtual environment directory and activate the environment. You should see the environment name appear at the start of your command line once the virtual environment is activated. Now let's install the necessary Python packages. First, we need the core Google API libraries. On your terminal, run the command showing on the screen. Next, install the Swarm package. Lastly, install the Streamlit package for building simple web interfaces and python.env for managing environment variables using an env file. And that's it for setting up the Python environment. Now let's move on to set up the required components in Google Cloud Console so we can start using Google Calendar API. Open your browser and navigate to console.cloud.google.com. If you haven't used Google Cloud before, you might need to set up a Google Cloud account. When you first log in, you'll be prompted to enter your payment details. Don't worry, Google Calendar is completely free with unlimited usage. You won't be charged for anything. Now that you're in the console, let's start by creating a project. At the top of the screen, click the Project Selector drop-down menu and select New Project. Projects in Google Cloud act as containers for everything you set up in the API, keeping configurations and resources organized. Give your project a name and click Create. This might take a few moments to process. Once project is created, click Select Project. With our project ready, we need to enable the Calendar API specifically for this project. From the project dashboard, go to the left sidebar and find APIs and services. Click on Library. This opens the full list of Google APIs available to your project. In the search bar, navigate to Google Calendar API and enable the API. The next step is to set up an OAuth consent screen. An OAuth consent screen is the interface that users see when your app requests access to their Google Calendar data. On the navigation menu, under APIs and Services, click OAuth consent screen. For the user type, choose External. if your app will be used by people outside your organization. This selection makes your app accessible to any Google account user once it's fully verified. Fill out the required information, like your app's name, support email, and developer email. Then click Save and Continue. In the Scope section, click Save and Continue to skip the step, as we will manage the scope directly in the script. In the Test Users section, click Add Users and enter the email addresses of the Google accounts you want to use for testing. Only these test users will be able to authorize your app until it's verified by Google. Review the consent screen, ensure everything is correct, then click Back to Dashboard. The final step is to create an OAuth client account. Under APIs and Services, click Credentials. On the top, click Create Credentials and choose OAuth Client ID. You'll see a few options for application types. Choose the application type your framework uses. In this case, choose Desktop App and give it a name. Then click Create. Click Download JSON to save the client credential file as client secret.json in your project folder. The JSON file contains everything your app needs to authenticate. And we are done setting up everything in Google Cloud Console. Now we can move on to the app development. Create a Python file and name the file googleapis.py with an underscore. In Google Cloud, the process to connect to Google APIs, whether it's Gmail, YouTube, or Google Calendar, is exactly the same. The only differences are the API name, API version, and scope, which specify the data permissions you'll need. And we will use the Google APIs module to create a function to simplify Google API client creation. In the module, import the required Python packages and create the createService function as shown on the screen. When using the createService function to construct a Google API client instance, we need to pass 4 things. The client secret file, which we downloaded when we created an OAuth client account earlier, the API name of the Google API service, API version, and permission scope. Prefix is used to differentiate the accounts that connect to the same API service. When we call the createService function, it'll first check if the token files directory exists first. If it doesn't, it will create the directory. Then we'll check if a valid token file in the token files directory already exists. If it does, the function will use it directly to load the session, so you won't have to reauthorize. If there isn't a valid token, or if the token has expired, the function will open a new browser window where you can sign in to your Google account and authorize access. After successful authorization, a token file will be saved in a folder named Token Files in your current directory. This token file allows you to avoid repeated authorization prompts in future sessions. Once authorization is complete, we then use the build function to create a Google API service instance by passing the API name, API version, credential object from the authentication. If the service creation is successful, prints a message to display the Google API connected and returns the service object. This service object serves as the bridge to the Google API service you are connecting to. In cases where service creation fails, the function will catch the exception. It then prints an error message explaining the failure and deletes the token file to prevent issues with an invalid token. This way, if service creation fails, you'll be prompted to authorize again the next time you run the function. Finally, the function returns none, signaling that the service instance couldn't be created. Create a Python file called prompts.py. We're going to use the prompts module to store prompt templates. To ensure we don't overwhelm an agent with too many tools, for this app, we will create 2 agents. a main agent serves as the entry point who is responsible for task delegation and non-calendar related tasks. Then a calendar agent who is responsible helping us to manage our Google Calendars. In the main agent system prompt, I am going to say you are a main agent. For calendar-related tasks, transfer to Google Calendar agent first to ensure anytime the main agent receives calendar-related requests, transfer the request to the Google Calendar agent. For the calendar agent system prompt, specify that the agent is equipped with Google Calendar functions to manage the user's Google Calendar. Then include examples and usage instructions for the functions the agent can access. To provide the tools for the calendar agent to use to help managing users' calendar, create a Python file called calendar tools. In this module, start by importing JSON and the createService function from Google APIs, which will help us establish a connection to Google Calendar. We'll also specify the client secret.json file for authentication, which includes necessary credentials to access the API. To construct a Google Calendar client object, create a function called construct Google Calendar client with a parameter called client secret to accept the client secret file path. Inside the function, define the parameters, API name, API version, and scopes to connect to Google Calendar API. The calendar scope will grant full access to manage the calendar. We then call the createService function to create the Google Calendar API client instance and returns the client object. In the next section, call the construct Google Calendar client function to construct the Google Calendar API object when we load the module. To create a new calendar, define a function called createCalendarList with a parameter named calendar name. This parameter will take in the name for the new calendar list we want to create. Inside the function, create a dictionary called calendar list with a single key value pair. The key should be summary, and it will hold the value of the calendar name parameter. This dictionary represents the data that will be sent to the Google Calendar API. Next, call the calendar list insert method from the Google Calendar client, passing in the calendar list dictionary as the body of the request. This method sends a request to create a new calendar list on the user's Google Calendar. We then execute the request to confirm the creation. The function returns the newly created calendar list dictionary, which contains details such as the unique ID and calendar name of the created calendar list. To list calendar lists, define a function called listCalendarList with an optional parameter named max capacity. This parameter will specify the maximum number of calendar lists to retrieve, and by default, let's set it to 200. If max capacity is passed as a string, it will be converted to an integer within the function. Inside the function, start by creating two empty lists, all calendars, to store the full list of calendars retrieved, and all calendars cleaned to hold a processed version of each calendar with only the relevant details. Also, define a variable called nextPageToken and initialize it to none. This token will be used for pagination to retrieve more items if they exceed the single page limit. Another variable, capacityTracker, is set to 0 to keep track of the number of calendars retrieved so far. We then enter a while loop that will continue retrieving calendars until the capacityTracker meets or exceeds max capacity. In each iteration, we call the calendarList method from the Google Calendar client, specifying the max results as the minimum value between 200 and the difference between max capacity and the capacity tracker. This setting ensures we retrieve up to the remaining number of calendars without exceeding the capacity limit. If there are any calendars returned in the current batch, they're added to the all calendars list. and the capacity tracker is updated to reflect the count of calendars retrieved so far. If this count meets or exceeds max capacity, the loop breaks. We then check if there's a next page token returned, and if it exists, we update our next page token variable to continue fetching on the next loop iteration. If it doesn't exist, meaning we've reached the end of all available calendars, the loop will end. After the loop, process each calendar in all calendars to extract key information. Append a dictionary containing the ID, name, and description of each calendar to all calendars cleaned. The description field is set to an empty string if it's not available. Finally, the function returns all calendars clean, providing a streamlined list of calendars with essential details only. To retrieve events from a specific calendar up to a defined limit, create a function called listCalendarEvents with two key parameters, calendar ID and an optional max capacity. The calendar ID represents the unique identifier for the calendar from which events will be retrieved. The max capacity defines the maximum number of events to return, defaulting to 20 if not provided. If max capacity is passed as a string, the function converts it to an integer to ensure correct handling. Within the function, start by initializing an empty list, all events, to store the fetched events. Also, define a variable named nextPageToken set initially to none, which will be used to handle pagination when retrieving multiple batches of events. Additionally, a capacity tracker variable is set to 0. To monitor the total number of events fetched during execution, the function then enters a while loop, which continues retrieving events until the capacity tracker reaches or exceeds max capacity. In each loop iteration, call the eventsList method from the Google Calendar client, specifying the calendar ID for the source calendar, and set the max results to the minimum value between 250 and the difference between max capacity and capacity tracker. This step ensures that no more events than necessary are fetched, respecting the defined limit. If any events are retrieved in the current batch, they are appended to all events, and the capacity tracker is incremented by the number of events retrieved. If the capacity tracker now meets or exceeds max capacity, the loop breaks, concluding the events retrieval process. Otherwise, if a next page token is returned, assign this token to next page token for continued pagination. If not, meaning no further pages are available, the loop will end naturally. Once the loop concludes, the function returns all events, providing a complete list of events from the specified calendar up to the defined maximum capacity. The final function in this module, insertCalendarEvent, is designed to add a new event to a specified calendar. This function requires a calendar ID to identify the calendar where the event will be added, and accepts any additional event details as keyword arguments. Inside the function, start by creating the request body for the event. Convert the keyword arguments passed into the function into a JSON-compatible format by loading them with JSON loads. This approach ensures that all event details are structured correctly for the API request. Next, call the eventsInsert method on the Google Calendar client. Set the calendar ID to target the specified calendar, and include the request body containing the event details. Execute the request, which submits the event data to Google Calendar. The function then returns the created event object, which confirms that the event was successfully added to the calendar and provides relevant information about the newly created event. And that's all the calendar functions we are going to create for this tutorial. Now let's move on to creating the AI agents. Create a Python file called agents.py. We will be using the agents module to create and manage AI agents for the app. For the import statement, import the libraries shown on the screen. To keep the cost to a minimum, create a constant variable called model and set its value to GPT-4o mini. The GPT-4o mini model is a more compact and efficient version of the GPT-4o model. It's ideal for smaller projects or applications with limited resources, where the full power of GPT-4o may not be necessary. To enable communication between different agents, create two functions, transfer to main agent and transfer to calendar agent, to return the designated agent. Moving forward, define the main agent. Here, we're giving it the name main agent and setting it up with the GPT-4o mini model. We then assign it the main agent system prompt to establish its primary instructions. For the default tool available, assign the transfer to calendar agent function to give agent ability to switch to the calendar agent when required. Similarly, create the calendar agent with the name Google Calendar Agent and uses the same model, GPT-4o mini. Set its instructions via calendar agent system prompt, defining the calendar-specific functions and workflows it will handle. The calendar agent is assigned the transfer to main agent function, allowing it to pass tasks back to the main agent when needed. To expand calendar agent's capabilities, add the calendar functions, list calendar list, list calendar events, insert calendar event, and create calendar list. By adding Google Calendar specific functions separately, we can organize the tools more easily. That's all for the agents module development. Now let's move on to the final part, the main script development. Create a Python file called app.py. For the import statement, import the main agent from the agents module. Then import Swarm and Streamlit to connect to OpenAI and create the UI. For the entry point, insert the main routine. Inside the main routine, we'll start by setting up the basic components to create our Google Calendar AI agent interface. First, create an instance of Swarm and assign it to the variable Swarm client. This Swarm client will create an OpenAI client and manage interactions with the AI agent throughout the program. Next, we assign main agent from our agents module to the object agent. This agent will serve as the entry point AI agent that processes user inputs. Moving into the Streamlit setup, we begin by setting the title of the app to create a Google Calendar AI agent. This title will appear prominently at the top of the interface. Now, we'll establish a simple message handling system. Check if messages exist in Streamlit.session state, which Streamlit uses to keep track of interactive elements across sessions. If messages doesn't already exist, we initialize it as an empty list. This list will store each message exchanged between the user and the AI assistant, keeping a continuous conversation record. Next, set up a loop that iterates over each message stored in Streamlit.session state.messages. For each message, we use the Streamlit chat message function to display it in a chat format. If the message role is assistant, we display it with a robot avatar. If the role is user, it shows up with a user avatar. Then we render the message content in Markdown, so the displayed text can support formatting if needed. Following the loop, we add the chat input feature where the user can enter prompts. If the user types something, this input is stored in the variable prompt. We then append this prompt as a new entry to Streamlit.session state.messages with the role of user and its corresponding content. Once the prompt is processed, we display it back to the user using another chat message block marked with the user avatar. Immediately after, we create a new chat message block for the AI response. To generate a response, we call the run method from Swarm client. Inside this method, specify agent as the agent handling the prompt and pass in the list of messages. This includes the latest prompt, so the AI has the full context. The AI response is then rendered using Markdown to display it as part of the chat interface. Finally, add this AI-generated response to Streamlit.session state.messages as a new entry with the role assistant, keeping the conversation history updated for further interactions. Now let's test the app. Launch your terminal and run the command streamlit run app.py. Looks like my client file is invalid. Let me take a look. Oh, in my file, I have a dash instead of an underscore. Now let me restart and try again. Alright, this time I am getting the prompt to authenticate. Follow the instruction to grant permission to the app. If everything goes smoothly, you should see the message, the authentication flow has completed. You may close this window. Now let me put the app and my Google Calendar side by side. Let's start the request with create a calendar called movie showtime. Looks like there's still an error somewhere, and the error is coming from the calendar list API call. Let me take a look. Oh, it should be calendars instead of calendar list in the API name. Now let me fix the error and replace the function name with something more appropriate. Also, don't forget to update the function name in the agents module. Now let me try one more time. Alright, so this time we are getting the response. The calendar movie showtime has been successfully created. If I refresh my calendar, the movie showtime calendar is now created. For the next test, let's say, I want to add 2 different events to the movie showtime calendar. And the events are added successfully. Keep in mind that the app serves as an example. To ensure the workflow is executed correctly 100% of the time, you will need to update the functions to address all the scenarios. I just noticed that the AI agent just created a duplicate calendar for the movie showtime. Let me delete the duplicate calendar and try again. Okay, this time the event is added correctly. For the next test, let's ask the AI agent to return my movie showtime events. And it successfully returned the 3 events I just added. For the last test, I'm just going to ask the AI agent to show my calendar list and create 2 more calendars called Project Deadline and Vacation. And all the requests are completed successfully. So that concludes everything in this how to create your own Google Calendar agent tutorial. And I hope you found this lesson helpful and informative. If you have any questions or suggestions, leave them in the comments below. Don't forget to like the video and subscribe for more tutorials. Happy coding! See you in the next one.